Guys, so today we're going to be doing our test review on rational expressions. So right now I want to go over a problem with you guys on graphing a rational expression. So on your review paper I went ahead and gave you. Let's go ahead and do number 19 together. Alright, so everybody should be there at this point. Alright, so number 19. Alright, we are trying to graph this rational expression right here. Alright, can somebody tell me what the first component we need to get is? Annie. Right. I would say let's go ahead and start with the horizontal asymptote. But it doesn't really matter, but the horizontal asymptote is always going to be the easiest one to get for us. Okay, it's going to be very quick. Alright, so the horizontal asymptote. Can somebody tell me what we're looking for? Yes, Bree.
So we have to look at the exponents on the coefficients.
Mm-hmm.
You have to look at the exponents to see if the denominator is greater or not. But since they're the same, we really look at the coefficients.
Right. So what we're looking for is the degree of the numerator and the degree of the denominator, all right? And we're comparing them. Okay, so in this equation, all right, the degree of our numerator is what? 2, right? So we know that m is equal to 2. All right, what is the degree of our denominator? 2, right, so n is equal to 2. All right, and like Bree said, when your degrees are the same, we're looking for the ratio of the leading coefficients. So remember, leading coefficients are the term that's going to go with your highest exponent, all right, the number in front of them, okay? So in this case, all right, our leading coefficient up here is a 1, right? When it's not written, it's an understood 1, okay? And then 3 is our leading coefficient here. So we have a horizontal asymptote at y is equal to 1/3, right? The ratio of those coefficients, okay? All right, horizontal is going to be the easiest one to find. All right, so now can somebody tell me what we need to find next? Anybody? Okay.
Vertical asymptote?
Sure, we'll do that. All right, so to get our vertical asymptote, we can also get our holes at the same time. What we need to do is go ahead and start simplifying. All right, so if we simplify, what can we use to simplify our numerator? X method, right, because it's a trinomial. All right, so go and use X method. We have -4 in the bottom, 3 in the top. What can we use?
-4, -1.
-4 and 4 and -1, right?
Yeah.
4 and -1. All right, so that means we're going to have x plus 4, x minus 1. All right, how about our denominator? How can we factor that? GCF, right? What will be our GCF?
3x.
Right, 3x. Right, so that means we have an x plus 2 left over, right? Okay, so now we have our simplified form. All right, does anything cancel?
That's an x plus 3.
Yeah, x plus 3.
Oh, you're right, my bad. Sorry. Thank you. X plus 3. Okay, does anything cancel? No. Okay, does that mean we have any holes?
No.
Correct, we do not have any holes. Okay, so we have no holes. All right, now do we have a vertical asymptote?
Yes.
Right, we have 2. Okay, remember for vertical asymptotes and holes, we need to set our denominator equal to 0 and solve. Okay, so to do that, we set each factor equal to 0 and solve. All right, so we solve each of these. Here we just get x is equal to 0. And then here we'll get x is equal to -3. Okay? All right, those are both vertical asymptotes. The reason for that is because they did not cancel. If they do not cancel, your denominator is a vertical asymptote. If it does cancel, it is a hole. All right, so we have a vertical asymptote at x equal to 0, and another one at x is equal to -3. All right, now remember with vertical asymptotes, you denote them as x is equal to because it's a vertical line. All right, that's how we write vertical lines. Okay, not y equals. That'll be a horizontal. All right, now is there anything else we need to find? Yeah.
X and Y intercepts?
X and Y intercept, exactly. x-intercept, all right, and a y-intercept. All right, so how can we find x-intercepts? Right, we said the numerator equal to 0 and solve. Okay, so here we set x plus 4, x minus 1 is equal to 0. All right, what do I get if we solve this? Right, we would get positive 1 and a negative 4, right? So we get x is equal to negative 4 and positive 1. All right, now do either of these fall in any holes or for asymptotes or anything? No, okay, good. So that means we can use them. All right, so x-intercept. Remember, these need to be written as ordered pairs, okay, because these are points. We have negative 4, 0, and we have 1, 0. Okay, what about y-intercepts? How do we get y-intercepts? Right, so what we're going to do is, remember the y-axis, right, x is equal to 0. So we plug in 0 for x, okay, in our entire equation. If we do that, remember, everything that doesn't have a variable is the only thing that's going to be left. Okay, so it's really just the ratio of your constants. All right, now, the thing about this is, on our denominator, do we have a constant? No, okay? So ultimately, that means we're going to be dividing by 0. Can we do that? No, so does that mean we have no y-intercept? Right, we have no y-intercept. All right, now we can go ahead and graph this, right? Okay, we have all of our pieces. All right, so let's start with graphing our asymptotes. So it looks like we have a horizontal at a third. We have no holes. We have a vertical asymptote at 0. Another one at negative 3. All right, we have a x-intercept at negative 4, 0 right here. And another one at 1, 0. All right, that's all of our pieces. So remember, from here, we're not exactly looking for extremely precise points. All right, we can use our asymptotes, we can use our calculators, we can use our intercepts. Just go ahead and do a rough sketch here. All right, that's what we're looking for. All right, so here, all right, let's go ahead and graph. All right, everybody get your calculators, and let's just graph the original. All right, make sure we're going to sketch this right. All right, good. Has everybody had a chance to graph? Okay. All right, so when we sketch this, it looks something like this, right? So pretty accurate. Okay. All we're doing is a rough sketch. All right, we don't need too many precise points. All right. Are there any questions on this problem? Okay. All right. I would like you guys to go ahead and do number 20 by yourselves. I will be coming around the room for anybody with questions, you need some help. All right, so go ahead and get started on that. And then at the end, we will come together and go over this problem. So to find the other coordinates of a whole, what you're going to have to do is take your simplified equation. All right, so break this down to simple. This simplifies it to 2 looks like it goes away. Alright, so you're left with a 1 in your numerator, right? And this goes away, so it's just 1 over x plus 4, right? So what you need to do here is take your x coordinate for your whole and plug it into that equation. Okay. Right, and that will give you your y value for your whole. Now you can't do it in this equation because if you plugged in your x value for your whole here, right, you would just get the divide by 0 and give you an error. Right, that's why you have to do it in your simplified version. Okay. Yes, ma'am.
What if you do things like that?
For your horizontal asymptote. So there are 3 cases with horizontal asymptotes. Either you're going to have none, you're going to have one at 0, y equals 0, or you're going to have one at the ratio of the leading coefficients. Okay. So do you remember which one is not going to have a horizontal asymptote? Right, right. So when the top is larger in degree, right, the numerator is larger in degree, you're not going to have a horizontal. Okay, and when we just did 19, they were even, right? Okay, so we had one there too, right? Now that was at the ratio, right, the ratio of the leading coefficient. So the denominator is greater, you're going to have one at y equals 0. Right, and that's just your x-axis.
Thank you.
When you write holes, so holes are going to be a coordinate, right? And this is something we went over yesterday, but not too much. Alright, so the way you need to get the y coordinate is going to be take your simplified version of your rational expression, right? Okay, so you see your x minus 2 goes away, x minus 2 goes away, so you just left with 1 over x plus 4, right? Okay, so then you would take your x coordinate for your hole and plug it into the simplified version, and that'll give you your y. Was it 2? Alright, so you get 1 over 2 plus 4, alright, so 1 over x. So it'll be 2, 1/6. Yep. And you have to do it in the simplified version. So if you do it in the normal without getting rid of your whole, it's just going to give you a divide by 0. So it has to be the simplified version. Yes, sir. Right, yeah, so horizontal, there's no real math involved. What you need to look for is the degrees of your numerator and denominator. So remember, degree is just your exponent, right? Okay, so up here are degrees 2, degrees 2 here. Alright, since they're even based on our rules of horizontal asymptotes, it's just going to be the ratio of the leading coefficients because the degree is. Okay, so your leading coefficient would just be 1. Here's a 3, so it's 1 there. Right, and this one, now they're not the same, right? So when the denominator has a higher degree than the numerator, right, there's still going to be a horizontal asymptote, but it's just going to be at y equals 0. Okay? Right, so there would be a horizontal asymptote. This is the graph for it, right? You kind of see it right here. You see it comes up and then turns here, right? So it's never crossing this x-axis. Right, that's usually a good sign that's going to be y equals 0. But anytime your denominator degree is higher than the numerator, it's going to be y equals 0. Anytime. Okay?
So this is not going to change this. Does that mean I don't have any points?
Let's see. Okay, for your x method, you're trying to get a positive 2. Yeah, negative 4 plus 2 would be.
So they should be switched.
Mm-hmm. Yep, your signs will be switched. So then you have something that cancels. You would have
So it'd be a negative 2 and positive 4.
Mm-hmm. The y value? Okay. So the y value for a whole, what you need to do is first get your simplified version of the equation. Right. Right, so everything cancels here and here, right? Your whole will end, so you have 1 over x equals 1. Right? That's your simplified equation. Okay, what you need to do is in that simplified equation, plug in the x value you got for your whole. Mm-hmm. Yep. So it would be like